Okay, transportation process. The geological cycle, it is one of the processes transportation. Due to the transportation of rocks, the soils are also constituted in the soil formation. So therefore there is a different types of transported soils. So screen is not sharing. Okay. Screen share అవుతుందండి. Okay. Okay, so types of transported soil. So first one, okay, next one. Types of transported soil. Water transported soil. The soils which are again transported types of transported soils. So water transported soils, wind transported soil, glacier deposit soil, and gravity deposit soils are available. In the first water transported soils, if the soils are deposited at the bed of the river. Okay, the bed of the river. If the soils are deposited at the bed of the river, then it is known as alluvial soils. This type of soils available in Telangana and APA region. Okay, next one. The soils are deposited at the bed of the lakes or ponds. What is the difference between river and lake means? River is a continuous and narrow type of water area, place. Lake means it is not moving at any place. It place only at one place. It is very wide area. So the difference between that is the difference between river and lake. The soils are deposited at the bed of the lakes is known as lacustrine soils. Lakes means lakes and lacustrine soils. River means alluvial soils. If the soils are deposited at the bed of the sea, it is known as marine soils. You are also know. So you have to keep it in mind only for the river. River at the bed of the river, alluvial soils. Okay. Okay. Next one. Wind transported soils. Wind transported, if the soils are deposited by wind, are known as erosion soils. So due to the in desert area, if you go at desert area, if one structure if the soil is deposited high at one day, and it is next day it is maybe continuously flowing, it is disappear, it hides. So soils are deposited by wind also. Okay, so if the soils are deposited by wind is known as erosion soils. Some very high storms, what we hurricanes, due to hurricanes and large storms, this type of soils will be formed. Okay, these soils have low density because just normally deposited. So high compressibility, low bearing capacity. So low density means high compressibility. So if you further increasing compact effect, it is very compressible, and it's having, so due to high compressibility, the bearing capacity is very low because density is low, bearing capacity is low. So okay, next one, it is having large permeability. So due to low density means high voids present in the soil. So therefore, due to heavy gaps in the soil, so the water easily going from one place to another. So that automatically permeability is having high. Next one, glacier deposited soils. That means ice. So the soils are deposited, transported due to glaciers. That means if the soils are some heavy, if you watch in ice age, the very icebergs are moving from one place to other place. So due to glaciers, if the any constitution materials are attached into the glaciers, so due to this process, again the glacier soils are formed. The main example for the glacier soils is drift and tilt. So remember this point. It is mostly asking in the previous questions and any competitive exam is, due to the glacier deposit, what type of soils are formed is drift and tilt. Next one, gravity deposited soils. So you know that in very in hilly area, top of the soil, top of the rock, transported due to the gravitational force and deposited at the bottom of the hill. So due to this gravitational force, the soils are formed due to the gravitational force only. So this type of soils is known as colluvial soils. Okay, the main example for this type of soils is talus. Okay, found in this type of soils found at the foot of the cliffs. It is presented at the near the hills. Okay, so major soil deposits in India is not very important. So you all also know that. So it is not very important topic. Okay, next one, types of soils. It is most important type topic. So next one, type of soil: fine grained soil to coarse grained soil. In fine grained soils, clay and silt. Fine means very fine, small particles are available. These fine grained soils are mainly caused due to chemical decomposition. Okay, okay. Next one, coarse grained soil. These soils are formed by physical disintegration. So due to physical disintegration, large broken stones are formed. So that's why gravels and sands are formed. In fine grained soils, so chemical decomposition formed. So due to chemical decomposition, rocks are formed into a smaller particles. So therefore, silts and clays are formed. Clay having smallest particle size. Silt some more better, some better, some high particle size. Sand is more. Gravel is high particle size. So next one. So yeah, these are already discussed in the in the last class. So that is which are proportional to surface activity, which are major effect in cohesion, proportional to surface area. Okay. So next one, gravitational force are major force in the because already discussed in the last topic. So gravel and sand are mainly effects on the gravitational force only. So major effect is maybe internal angle of internal friction. It is mainly proportional to the weight. In case of silt and both coercive forces and gravitational forces are predominant sometimes. In case of silt, silt is in between. Clay have purely coercive nature. Sand and gravels is purely non-coercive nature. That means it is contact between the particles is only gravitational force and internal friction only. The clay have the attraction between the particles is completely attraction between the anions and cations, like particles between the positive charges in the surrounding surrounding top of the surface of the particles. But silt is in between. Some silts having sometimes friction and sometimes coarse natures, constantly called as silt particles. Okay. Next one, soil structure. The soil structure. The soil structure means the geometrical arrangement of soil particles in a soil mass is known as soil structure. Okay. The geometric arrangement of soil particles in a soil mass is known as soil structure. How the particles are arranged in a soil is known as soil structure. Some type of soils is some type manner, some soils having different type of structure. So how this depends upon the this type of structure is depends upon its particle size and its mode of formation. Some particles having large size, some soils having less size. Some soils are made of formation by transportation by water. Some soils are transported by river. Some soils are transported by glaciers. Some soils are transported by glaciers. So due to this constitution, commonly called, we have the soils having different type of structures. Next one, the structure of the behavior of soil is depends upon the soil structure. Based on the soil structure, different types of soils having different type of structures. Okay. If the soil having certain type of structures having certain structure, so due to the structure, the soil having separate behavior. So we have, for example, if one structure, one behavior, another structure, another behavior is present in the soil. So mostly the different type of structures are available. That is a single grain structure, honeycomb structure, fluctuated structure, and a dispersed structure, and a coarse grained skeleton. So these all are different types of soil structures. So that main one single grain structures. In single grain structure, the particles are arranged by in grain to grain contact. So the particles are arranged like a I will give a here, like the particles are arranged in a grain to grain contact and layer by layer like this manner. Okay, this is called a single grain structure. Okay, the void ratio may be loose or dense. So the void ratio may be ranges from 0.35 to zero point 0.9. So mostly so some like this type of void ratio may be zero point 0.9. If the point ratio, if the voids the particles are if we giving vibrations, the particles may be that means the shape will changes and settles like this manner. And this void ratio is decreases. Here most of the voids is available, more number of voids is present in the between the voids. Here there is no much more voids between the voids, so therefore here void ratio is very less, here void ratio is more. I will give an example for this. Whatever called it, it's in లేడీస్ జనరల్గా కిచెన్లో ఉంటారండి. వాళ్ళు ఒక ఒక గిన్నెలో ఒక లేదా ఒక ఒక ఏమంటారు ఒక ఒక బౌల్లో సాల్ట్ వేస్తారనుకోండి, దాని నిండా వచ్చేస్తుంది. దాని నిండా వచ్చిన తర్వాత ఏం చేస్తారండి, మళ్ళీ షేక్ చేసి వైబ్రేట్ చేయగానే మళ్ళీ దాని యొక్క వాల్యూమ్ డిక్రీజ్ అవుతుంది, ఇంకొంచెం సాల్ట్ అనేది పడుతుంది. సో అలా, సో ఈ లూజెస్ట్ స్టేట్ ఏమో ఇది. సో ఇనిషియల్ గా సాల్ట్ పోసినప్పుడు ఇదేమో డెన్సెస్ట్ స్టేట్. ఆఫ్టర్ వైబ్రేషన్స్ క్రియేషన్ the 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 gap will be formed and more soil will be penetrated into the or deposited into the beaker. So loosest state to densest state. So in the loosest state, so more soils are more less soils, less particles are formed, and due to the less particles more void ratio is present. Okay, so this type of structure is present. Okay, so this is the reason why void ratio ranges from 0.35 to 0.9. The main single gain structure is only due to the gravitational force and angle of internal friction between the particles. The void ratio may be ranges from 0.35 to 0.9 due to loosest state to densest state. Okay, next one, honeycomb structure. It should be like a honey. Honey means like like spear, one circle with attaches with more number of particles. So this type of single gain structure is present only gravels. Only this type of structures is single gain structure is mainly present in gravels and sands. Okay, gravels and sands. While honeycomb structure is present in the fine sand to silts, fine sand to silts, because particle size is very less, 0.00 to 0.2 mm. So this honeycomb structure is not a stable structure because due to the structure is present due to the presence of moisture around the particle. Due to the moisture present around the particle, this type of structure is present. So if after drying process, the water, the moisture present in the soil is evaporated. If the any load or any disturbance, any void, any vibration creates, automatically the structure disappears, and it again comes into the single grain structure. So honeycomb structure is not a permanent structure. It is very dangerous to the if any type of structure presents in the beneath the soil. If you are constructed on the above this type of soil, it very dangerous to the structure. So it is maybe found due to the cohesive soil such as fine grained particles. Okay, here the mainly the particle to particle contact between the, and also sometimes it's a small type of large, sometimes it's a small cohesion between the particles. The cohesion may be due to the presence of moisture present between the top of the surface of the particle. Okay, honeycomb structure. Okay, okay, so okay, we can support only static conditions only. Under vibrations and it may disappear the structure, so automatically the structure will collapse. Next one, fluctuated structure. The structure presents in only fine grained soil, that is example clays. Okay, single grain structures for gravels. Okay, the gravels having a large size. Honeycomb structure is for fine sands and silts, so vertical size is decreases. And fluctuated structure, this structure represents in only clay, very fine particles. So under microscopic view, the clay particles structure is like this way. Okay, like this way. So interparticle forces plays a predominant role in the deposition. Okay, mainly in clays, the attraction between the particles only electrical forces. That means charges on the surrounding of the particle or surface on the particle. I will give, okay, like under microscopic view, the clay particles will visible like a long strip of the particle. The here fluctuated structure, the arrangement is edge to face oriented. Here having face, one another clay particle having its edge, so edge to face edge to face orientation is available in the fluctuator structure. Okay, so it is called as here it is the at the edge it is known as edge. Here it is known as in this process, in this way we are called as face. So here in the fluctuator structure, the structure is presented due to the edge to face orientation. Okay, all type of these particles come together to form a flock. So whenever these all type of particles formed and come together at a place, then it is known as, generally we call as flock. So hence this type of structure name it as known as fluctuator structure. Whenever these type of clay particles are constituted or combined together at a one place, then the form is known as flock. So hence this type of structure is known as fluctuator structure. This structure has high shear strength because high attractive forces between the particles. Due to the high attractive forces, no compressibility, low compressibility. Due to when we apply any external load on the structure, it is very less compressibility. So due to less compressibility, there is no voids in the soil. So therefore, it is due to low compressibility and it is having high attractive forces, the water easily attracted and easily permeable throughout the structure. And also the next one. Next one, fluctuated structure having more strength compared, having more strength and high permeability. Same here, higher also same point. Single grain structure having more permeable and less strength. Single grain structure having more permeable compared to this structure, because single grain structure having more voids. So due to the more voids, high permeability available in the structure. So this is called as fluctuator structure. The main fluctuator structure is edge to face orientation. The edge to face orientation is mainly because of strong attractive forces between the particles. Okay, this structure is present only in silts only. Okay, next one, dispersed structure. This is called as dispersed structure. The same fluctuator structure, but is due to the fluctuator structure is changes into this dispersed structure. I will give a, okay. This is fluctuator structure. The fluctuator structure is changes into this structure. So if the particles is arrangement in this way, then it is known as dispersed structure. This structure is happens by applying of any external forces, or maybe due to temperature, or maybe due to strength, loss of strength. So then the fluctuator structure is changes into this type of structure. So whenever the particles is like this way, face to face orientation, here edge to face orientation, here edge to edge orientation, or face to face orientation is present. So whenever the particles having edge to edge orientation or face to face orientation, then it is called as dispersed structure. Okay. Next one. So remolding. What is mean by remolding? Remolding means the causes of loss of strength in corrosive soil. I will give you explanation. Remolding, the loss of strength. For example, in rainy season, any water present in these particles. After summer season, the water evaporated, or water may be transferred to the another places. So therefore loss of strength, or maybe due to the high pressure acting on the top of the soil, so automatically the shape will be changes into the display. So therefore in this manner the loss of strength will be happens in the soil. So therefore the remodeling causes a loss of strength in the corrosive soils. Next one, thioxotropy. Okay, after again coming from summer seasons to rainy season, and also the if the any soil having the overburden pressure is removed after a um, ఏం కనపడడం లేదు సార్, మరి ఇప్పుడు చెప్పలేదు ఏంటి? ఓకే, ఇప్పుడు కనిపిస్తుందండి. ఓకే,
వినిపిస్తుంది సార్.
స్క్రీన్ కనపడట్లేదా?
స్క్రీన్ కనిపించట్లేదు సార్, లోడ్ అవుతుంది. గోడకు
కనిపిస్తుంది.
షేరింగ్ అని చెప్పి నెట్వర్క్ ప్రాబ్లం.
దగ్గర నెట్ బాగానే ఉంది. Okay, next one, thioxotropy. Thioxotropy means the phenomenon of regaining of lost strength with passage of time with no change in water content is known as thioxotropy. After a long time, the overburden pressure is removed from the soil and it regains its original shape and original structure by passing of time, by passing by without change in water content. Again, this dispersed structure again regains its original strength. So the process of dispersed structure to fluctuated structure is known as thioxotropy. The from fluctuated structure to dispersed structure is known as remolding. Okay, next one, it occurs in remolded clays. Okay, it is face-to-face orientation or parallel orientation. The structure forms net repulsive force between the particles. So because same positive on the same side, so because of same positive charges, so automatically we get net repulsive forces in the structure. Okay, net repulsive forces in the structure. Okay, next one, combined structure. So this is known as um, coarse grained skeleton clay matrix structure. Okay, this is another type of structure is combined structure. In combined structure, again two types again two types of structures are available: coarse grained skeleton and clay matrix structure. In coarse grained skeleton, most of the particles are coarse grained particles. Coarse grained particles. Okay, it is smooth level. సరేనండి. ఓకే. నేను మామూలుగా చెప్పేస్తాను. సో, కోర్స్ గ్రైన్డ్ స్కెలిటన్‌లో ఎక్కువ శాతం కోర్స్ గ్రైన్డ్ పార్టికల్స్ ఎక్కువగా ఉంటాయి. క్లే మ్యాట్రిక్స్ తక్కువగా ఉంటుంది. సో, అందుకే దీన్ని కోర్స్ గ్రైన్డ్ స్కెలిటన్ అంటాము. అదే క్లే మ్యాట్రిక్స్ స్ట్రక్చర్‌కొచ్చేసరికి ఏమవుతుందంటే ఆహ్, ఆహ్, ఫైన్ గ్రైన్డ్ సాయిల్స్ ఎక్కువగా ఉంటుంది. అక్కడక్కడ కోర్స్ గ్రైన్డ్ సాయిల్స్ ఉంటాయి. సో, దెన్ ఇట్ ఈస్ నోన్ యాస్ క్లే మ్యాట్రిక్స్ స్ట్రక్చర్. ద whatever the content is more, then it is known as if the coarse grained content is more, then it is known as coarse grained skeleton. If the clay content is more, then it is known as clay matrix structure. So that is the today this is our topic.